In this video, I will use an example to illustrate the idea underlying data reduction. Imagine we're tossing a coin, and if we observe a head, we use the number 1 to denote that. If we observe a tail, we use 0 to denote a tail. So within each trial, we toss these coins for 3 times, and we collect the data. For instance, in the first trial that I did, I observed 3 tails. Then I write down 0, 0, 0. And this is a realization of the 3 random variable, which is also known as data. And then we repeat these experiments for another time, and I observe 2 tails and 1 head. This is another realization of the original random variables, so I collect another set of data. If we repeatedly perform these experiments for unlimited times, eventually you will see there are only 8 different possibilities, unique combinations of 1 and 0 you will see. And we call these 8 outcomes as the sample space of your experiment. Imagine we have a statistics on the random variable in the space R of n, and it maps the random variables onto a new space. Then, in the case where d is less than or equal to n, we say that since it makes the sample space a lot simpler, then the statistic achieves data reduction. The second thing is T of x actually produces a coarser space partition. Going back to the example, originally there are 8 ways to do the partition for the sample space. After we calculate the statistics, there are 4 different partitions of the sample space. Can be viewed as a partition of the original sample space, and the partition usually has fewer dimensions than the original sample space.